Give me a second. Okay, cool. All right, so now that most people are here, I think we can get started. So today we'll be talking about like benefits of different text editors. We'll be talking a little bit about the command line interface, and we're going to finish off with some Git and Git best practices. I know a lot of us, me included, struggle with Git sometimes, so we'll go into that. So a few announcements. Our application is going to be open until Friday, so if any of your friends are interested, just encourage them to apply. We're letting everyone in. We get this question a lot. Final batch of enrollment codes will be sent out Saturday, so mark that date. If you don't get it by Saturday night, that's when you should be worried. That's when you can make a final Piazza, like a private Piazza post. We're just waiting for all the apps to come in on Friday, and then we'll send them all out at once. Make sure to use your enrollment code on Cal Central to officially enroll in the class by Monday, September 7th. So for people asked about homework, we'll be assigning our first homework Monday or Tuesday next week. So make sure we're gonna add everyone to the grade scope like Tuesday morning. So make sure that you're officially enrolled by then. If you at any point want to drop this class, make sure to drop by the drop deadline, September 16th, because afterwards it's going to be pretty difficult to drop. Accommodations. If you have a need for accommodations of any reason, it doesn't really matter what the reason is. You could say that you need an accommodation. You want to miss lecture for like a single day, or you need to miss every Tuesday lecture. Just fill out the accommodation form. We know many of us are struggling in some way or another, so we're just going to go with the honor system on that one. We'll be having an FAQ Piazza post out soon, so if we notice there's a lot of questions on a specific topic, we'll get those out of the way. Feel free to, and once we get that out, feel free to ask a question on the FAQ. That way we have all the questions in one place so that people know where to look. We've been getting a lot of repeat questions, so we just want to make sure that that kind of time is cut down. Where will homework be posted? Gradescope. Everything is pretty much going to be on Gradescope, so just hang tight. We're gonna get there. So today, text editors versus IDEs. I know a lot of people get confused. I know many on the course staff were confused up until today, myself included. So we compiled research. We've done a little bit of thinking for you guys. After we talk about text editors and IDEs and choosing the right one, command line. Command line is going to save your life. It's going to cut down your development time a lot rather than just using Windows or the general user interface. After we talk about the command line, we're going to be using Git. We're going to show you guys how to version control your projects, not just coding projects, literally any kind of project. So let's get started. Text editors. Also, make sure to call me out if I talk too fast again. So I know I have a tendency to do that. Text editors. Okay, so text editors are literally anything that let you edit text. So this means that anything from Notepad++ to VS Code to Sublime Text to Atom, those are text editors, not IDEs. These are Notepad software where you're literally opening a file and that's all you really do. And they do have some IDE-like features. So some of these, like Sublime Text, VS Code, and I believe Atom as well, allow you to install plugins that make it behave like an IDE, that lets you do linters where it tells you like syntax errors, or add debugging tools so that you can have a fully functional debugger. So it's really important to differentiate these things. I personally use VS Code. It's good to understand what the, I'm gonna let you guys do the research on which ones you guys like best, because it's really up to personal preference. They pretty much all do the exact same thing. They edit text. There's a myriad of different reasons that you might want to use one over the other. So I'll let you guys do the research on that, but we're just gonna talk about like the differences between text editors and IDEs. I saw IntelliJ in the chat. That is an IDE, which we'll get into right now. So IDEs are things like IntelliJ, Xcode, and Visual Studio. This is not to be confused with Visual Studio Code. Visual Studio Code is a text editor. Visual Studio is an IDE. So IDE is an integrated development environment, meaning that it comes with pretty much every single dev tool you need to create a project and run it. So this does not depend on any extensions. You install it and you're ready to code. And IDEs let you access databases and write GUI code automatically. So this is one of the features unique to IDEs. VS Code, like VS Code, for example, if you want to design a GUI in Java, it becomes a little bit difficult. Same thing if you want to write design a GUI in C#, it's probably better to use Visual Studio rather than Sublime Text or VS Code. Debuggers. IDE debuggers are amazing. They're going to, we're not going to be using them too much because I think for the project, you'll pretty much only need like the debugging tools in a text editor, but feel free to use them. Debuggers and IDEs tend to have more features and they work a lot smoother than like debugging extensions you get on things like VS Code and Sublime Text. So that's something important to note. So when you're deciding what to use for a project, there's a lot of different things that you need to consider. One is system resources and speed. So IDEs use up a lot of system resources. I'm talking like RAM, CPU power, and they tend to be slower for the most part. It really depends. Like if I were to run a Java program straight from the command line in a text editor, it would go a lot faster than clicking run in IntelliJ. So that's one thing to keep in mind. Another thing to keep in mind is feature offerings. So by feature offerings, I mean which ones come pre-packaged and which ones come in via plugin. So I'll take VS Code, for example, because that's the one I use the most. They have a marketplace where you can download a bunch of different plugins that do a lot of things for you and make it more like an IDE. But Visual Studio comes with pretty much everything that you want in terms of like debugging capabilities and linters. It comes in already. So you might want to see if you want to deal with the hassle of installing them and going through every single thing that you need versus just having it prepackaged in an IDE. Debugging capabilities, I already mentioned this. IDEs tend to have better debugging capabilities. Vim is not mentioned. I am sorry. Vim is another text editor. I have had that time, so that's not really in scope. I still don't know how to exit Vim. I'm going to be completely honest. So back to text editors versus IDEs. Look and feel. You might want to choose one over the other just based on the look and feel. If you think pretty much everything else is equal. Shortcut customization. So for Vim, you can pretty much customize all your shortcuts, right? I've heard of this. I do not have practical experience, but it is a pain initially. But according to my sources, it tends to ramp up really quickly in terms of dev time when you have all your shortcuts like figured out and things like that. It does have a high learning curve. Yeah. So basically, this is all you really need to consider. There are other there's other things that you might want to consider, but these are the main things you should consider when trying to use a text editor versus an IDE. One thing that's not listed here is project scope. If you have a really, really big project that's going to require a lot of computing power, use an IDE. That pretty much overrules anything about a text editor because when you're working on a really large project, you don't have time to fiddle with all the different things that a text editor might come with, like figuring out configs for certain extensions. It can be a pain. If it's a really big project, just use an IDE. It'll save you so much time. Assembly gang, where are you at? I usually don't program in raw assembly, so I wouldn't know. Are there any questions on text editors versus IDEs before I move on? This is where I move on to command line. Pen and paper gang. If you like to write your code on pen and paper, feel free to do so. If your brain works like a compiler, go for it. Nothing against that. Let's see. Staff, is there anything that I missed just before I move on? All right, so it looks like I didn't miss anything. Just scrolling. Cool. All right, so I'm going to move on to command line. Excuse me. This is probably going to be something that you don't want to take notes for, even during the demo, which ran. I think no. For command line, I'll be demoing. You guys don't need to like remember any of this. You guys just need to know the concept behind it. So command line usually looks like this on the, sorry, there was no space for Linux, but Windows is on the left and Mac is on the right. So that's generally like how it looks like. So Unix-based command line, if you're using Unix, generally the shortcut to open the terminal or the command line is Control-Alt-T. For Windows, you want to, there's different kinds. So you can use the default. You can use the Windows Linux subsystem that comes with Windows, which gives you the commands of Unix. Windows default command line has very different commands compared to the Unix command line. So it really just depends on what you need, but for the most part, I've found that the Unix-based command lines have a lot more functionalities and they're more universal. So there's another way to get a Unix-based command line on Windows without using the Linux subsystem. That's Bash, which comes with Git. For those of you that are not familiar with it, we'll get through the installation instructions and stuff. We'll send out an assignment and instructions on how to install Git and how to get familiar with all this. So for Windows, to get the default command line, you want to hold Windows and press R. It's going to open up a run window in that text field. You're going to want to type in CMD, and then push enter, and that's going to open up your terminal. I believe for Mac, you do command spacebar to open up the spotlight, and then type in terminal and push enter to open up your terminal. So these are the different ways to open it, just to access it, for those of you that may not be familiar. So command line benefits, speed. So after like the initial learning curve, you're going to be working much faster than you would if you were using a GUI. And so initially, you're going to be learning the different commands, and you're still going to be training your muscle memory. So it's going to be a little slow, but afterwards, it's going to speed up really, really quickly. Automation. So I know a lot of you, when you some of you may have experiences with Git. So when you want to git add a folder and then you want to commit that and then you want to push that, there's 3 separate commands, but you can actually automate that with a shell file. So we'll show you guys how to do that later on. So automation is going to save you so much time because you literally just push in like 5 characters, like the name of your shell file, and then it'll run all the different commands in that shell file. So taking in user input is trivial. It's a lot easier to open up a program to the command line and take an input from that, rather than creating a GUI where you can take an input from there. It's a lot easier on the command line. So you guys will be using that in your project. Chaining commands together, specifically piping. Piping is when you can run a command, take the output from that command, and feed it into another command for it to run it. So let's say I create one command that lists out all the files in a directory. I can actually take that output and pipe it or give it as an argument to another command in the same line, and then that command may like filter them or do something else. Remote access is a lot easier on the command line. Many of you may have heard of SSH. SSH means it's basically just remote access through the command line. So you can access a different computer remotely. And you can traverse through the file systems, do what you need to do. But you will be limited to that. But you guys will find out that it's not actually a limitation in most cases, especially when you're developing. So, okay, command line demo. Let's see if I can get this up and running. So I will be using this thing. Let's go to desktop and command line demo. So can you guys see this? Oops. Can you guys see the window? Let me go into the chat. Okay, and I want to open up Git Bash. And so can you guys see both the window of the CLI demo and the Bash terminal? I'll turn up the font size. I think it was here. That's embarrassing. Oh boy, let me figure this out. Text, select. Here we go. So let's do something like 18. that actually makes it a lot easier. Can you guys see like the commands I'm running? Cool. Can I get another confirmation just before? Okay, cool. So let's me see. So we're going to go into some basic things. So I'm going to actually create a folder, just another folder called demo. So first one that we're going to be going over is ls. ls literally just means list the folders and the files in your current directory. lsa will give you all the folders. And when I mean by all the folders, it means that some folders and files may be hidden and may not be directly visible. So things like .git folders, which we will get into later, is hidden. So we're going to be able to see it, we need to do LSA or configure our system to show hidden files. So yeah, and if I want to, let's say, get all the files with a specific file extension, so I'll just do 2 text documents right here. And if you see, this shows us the 2 text documents. If I want to do all the text documents, it's *.text, and it'll show us only files with that extension. Now, what if we want to like go through different folders? So this is going to be the cd command, which means change directory. So the argument, so a command is basically, sorry if I didn't mention this earlier. A command is basically some kind of like characters that specifies what to do, followed by space separated things of like the parameters. So when I say ls, that means just list. When I said lsa, that means list all. And when I said ls *.text, it takes an *.text as a parameter, and it says we're going to filter only the text files. Does anyone have any questions on that before I move on to change directory? Cool. No questions, so I'm going to be moving on. Yeah, we're good on time. So I'm going to do ls once more. So we see the demo folder. All folders are followed by a /. So we can change directory into the demo. So use your command, which is change directory, and then followed by the folder name. And you'll see here, as we go into demo here as well, there's nothing in here. So let's just create another text file that just says demo. And we can, if we type in ls again, we can see demo. I don't have it installed on this machine, but if you type in man and then the name of your command, it'll give you the manual pages for the command. That way, if you want to know all the different arguments that you want to use for a specific command, just do man and then the name of your command. So now, we went into demo, so you can type in pwd, which is another command that just prints out your current working directory. So our current working directory is my user file, and then on my desktop, I have a CLI demo, and then we created another demo file. Now, what if I want to go back one? So all you have to do for that is cd space .. That goes back one folder. If you want to go, so I'm going to go back into demo. If you want to go back multiple, you can just chain them together with slashes. So this is one folder, and /.. means I'm going to go back 2 folders. If I wanted to, I could do it again and say, okay, I want to go back 3 folders. And if you compare this, our current working directory after I did the triple chain to my current, you can see that it just took out the last 3. So I'm going to just go back into it here because I'm lazy. So we're back in demo. Now we want to figure out how do we manipulate files. So let's actually do that. We're going to go into demo right here. We're going to say 1, 2, 3, 4, 5, 6, A, B, C, just some mumbo jumbo. And let's save that. So we're in demo. We type in ls again to find our file. So if you want to print out the contents of a file, you just say cat. Cat is the command to print out the contents of a file. So you say cat demo.txt. Make sure the file extension is specified. So that one, so you can see the contents of the file that we just edited. So what if I wanted to only get the first 3 lines? So when you want to get the first n lines of something, you type in head-n, the number of lines, and then your file name. So these are all parameters. N means number of lines. How many lines? we say 3, and then from which file is text. So you'll see that we get the first 3 lines. If we want the last, well, in this case, the opposite of head would be tail. So we do -n3 demo.text, and it gives us the last 3 lines. So that's a little bit on file manipulation. If you want to create a folder, it's the make directory command, mkdir. And you type in mkdir followed by the folder name, which let's say is demo2. I hope it's not like, I hope these file names aren't too confusing. Are they confusing? Do you want me to like spice it up a bit or make it more like real world scenarios, or is that fine? Spicier. Okay. Cool. Okay, I'll do that in a little bit. So we made demo2. So if I type in ls again, you can see that we have demo text and demo2. So make directory makes a new folder. Now let's go into demo2. So you can see that I typed in pwd to show our current directory. We're in demo2. There's no files here. So how do we create a file from the command line? So the command for that is touch. And what you do is type in touch followed by the name of the file and the file extension. If you don't specify the file extension, it's just an extensionless file, which can lead to problems. So we'll type in super secret GitHub codes, right? .text. And that creates a text file within demo2. I'm not sure how to make this. Let's do this. There we go. That ruins. That's fine. So this is our text file right here. So super secret GitHub codes.text. So we created a text file. Now, what if we wanted to copy a file to a different file, or just create a copy within the same folder? So let's go back to demo using cd, and we'll see that we're in demo. One aside, you guys don't need to write any of this down. We're going to release a cheat sheet that has all of this, and this is meant to be more of like knowing what it does rather than how it does it. So once we give you guys the cheat sheet, you guys will be able to do this just fine. So copy. So this is a copy command. To create a copy, what you do is you do copy. We're going to try demo.text and move it into demo2. So it's copy followed by the file name, followed by the folder you want to copy it to. So if we go into demo here, we'll see that we got a copy of the demo here, copy of the demo.text file. Now, if we want to copy and rename a folder, we do copy -r for folder, and we say demo2, and we're going to duplicate this folder and call it like secret codes. So let's do that. And you'll see that we have secret codes with this exact same file. And now, let's see, we're at 736. Cool. So if I want to rename a file because I don't like its name because they're too bland and not spicy enough, so we're in demo. We want to rename demo.text. What we do is type in mv, which is move. We're not moving anything. We're just moving it back into its own place with a new name, essentially. So we have demo.text and we say not secret codes, right? So if you do that, you'll see that it got renamed over here. Let me move this up. Not secret codes.text. And if you want to rename a folder, it's pretty much the same thing. It's mv original folder name followed by new folder name. Now here is where it gets a little spicy. So here's our secret codes, right? Or here's our not so secret codes. Let's see. What we want to do is extract certain data. What if we know a single code, but we don't know which line it's on or where in the file it is? We know it's there, but we want to find the line that it's on. This is the grep command. Grep basically grabs the text that you want. So if I want to say grep, let's see. If I want to find ASD in some file, let's see, I think it was this. There you go. It tells me it tells me all the occurrences where it has ASD. If I wanted to say like, super secret code here, just to like add some twists to it, it should theoretically print out the line. So what this does, it prints out the lines of a certain occurrence. Now, I don't know if you have time for anything that's, oh, piping. So if I want to take the output of a file, let's say, like if I do cats, let's see, cat, not secret code. So this prints out the content of the file. What if I want to take the output that it prints out, and rather than take it directly from the file, take the output of the file from cat, and then I want to try and filter it afterwards. So that's where you do the piping. So let me actually clear this up so it's a little bit more clear. So we have not secret codes, and we want to print it out. So this is what we would normally do. What we would do is add this pipe symbol, which is in coding you would use OR. And what you do is you treat everything after the pipe as a completely new command, but the arguments to that is everything to the left of it. So what we're going to do is take the output of cat not secret codes.txt, and then we're going to filter it and say I want 1, 2, 3, and that gives me all the lines that 1, 2, 3 is on. So did I go? So what about strictly ASD? Yeah. So let's actually do that. Actually, we can use this command as well. So we said strictly ASD. This one gets, I believe there's a function argument, or a command argument that says strict or something where it says only the occurrence of that and not as a substring. I don't know that off the top of my head, so that's an exercise for you guys. Find out what it is. You can also type in man grep in Google, and it'll give you the same man pages as it would in the command line. Are we good to move on? Is there something that you guys have questions on? Is there like an or for grep? Like, can we have lines that have this? Let's see. We have this, and so if I want, so we have this. Maybe we can do this. No, I don't use grep too much, but maybe it's worth investigating because I don't have most of these commands off the top of my head. That's one thing. If you don't use it too much, you're probably gonna forget it because it's good practice to just know where to look rather than what it is, because a lot of times you're gonna have too much stuff to remember. So can we move on to Git? Because I feel like that's a little more important. Are we good to go? Cool. Okay, so we're going to do the Git demo in just a little bit, but back to the PowerPoint we go. So let's see. So version control systems. Why do we use them? So first, you want to keep track of progress over time. If you have some kind of project, it's good to not only keep like saves of it, but it's also good to just know when you did something. And in case something goes wrong, you can restore it to a previous version. And another reason, they're all listed here. I'm just going to go into each and every one of them. Collaboration on projects. If your partner messes something up and you want to go back, there's always a way to do that. And you can, during each change, you can give it a label or some kind of message so that you know what you did rather than just what it looks like. And this is kind of like a byproduct, but you always have backups. So I personally use Git to like keep like a private storage of like certain files and documents I have. So if I want to go to a different machine, I can just pull them all there. For example, if I have a laptop and a desktop and I'm submitting a resume on my desktop and I move to my laptop, I can just go to that version control system, find the file, and then that's how we get it. And yeah, not restricted to coding projects. So you can do this with digital art. You can do this with a lot of things. You can do this with CAD models. So that anything that is a file can be tracked essentially. So some things that implement version control systems are Microsoft Word. You can are similar to Google Docs. You can see the revision history. Internet pages also keep track. If you guys heard about archive.org, it keeps track of different, like it creates different snapshots of the internet pages over time. And Git. So we're going to be learning about Git. Yes, you can host websites on GitHub pages. Yeah. Let's see, before I move on, pull request versus pushing directly to master. That is a convention thing, which we will get into. So we're going to be using Git, which is one version control system. There are many others out there that you can use, but the most widely used and most widely adopted one is Git. So we're going to be using that one. So I know that many of us that have experience with Git may not have as much experience as we want, because sometimes things go wrong, and pretty much the only way is to delete something and then completely reclone it, which wastes so much time, especially if you're working on a large project like the ones in 61B or the ones in this class. So I'm not calling anyone out. If anything, I'm calling myself out, because teaching this class forced me to learn everything that I needed to know to teach you guys. So let's get into it. Git concepts. So when you initialize, there's a bunch of things that you have to do to get into the workflow. First is initializing a repo, adding files to staging, committing files, pushing files, branching, merging, rebasing, merge conflicts. I hate merge conflicts. We can't really avoid them. So we're going to be talking about all of these in just a sec. So initializing a repo. Before we move on, is there any questions about version control systems in general, or specifically about Git? If you guys have any questions, just dump them in the chat. I check it routinely. Maybe the course staff can answer it as well. So basically what you want to do is find some folder where you want to create your snapshots of your project over time. So a Git always has some kind of working directory. So here's a picture of me initializing a Git repository within a certain folder. So what Git init does, you need to declare the current working repository as a Git repository. It just means that this is where all your files are going to go that you want to keep track of. And these repositories are made of commits. The commits are snapshots of your repository. So let's say I made a change to a file, I would commit it, and that creates a snapshot that I can access at or go back to at any time. If I change it again, I create another commit, which is another snapshot, and it keeps a trail, a chronological trail of the snapshots you take or the commits you push. So how it would work is we have this working directory. This is just our folder. This is where we initialize a few of our files. So let's say hello-world.txt and hello-cloud.txt. For this example, we're only going to be focusing on hello-world.txt. So staging area means that you want Git to keep track of this file. So we're going to be going into the commands later on. But basically, what we want to do is, let's say I made some changes to this. I created this hello-world.txt file, and I made some changes to it, and I want it to be ready to be able to commit it to keep a snapshot. What I would do is I would push it to the staging area. So this means that, okay, this is ready to be taken a snapshot for. Now, you might be wondering why we don't go directly to commits. It's because we may want to keep track of may want to commit different files at different points in time, or we may want to commit different files under the same label. So, which is why we don't do all of that. So we don't just go working directory to commit for every single file. Now, after we're done with this, so that means that we're done with this file, it's ready for staging. We pushed it to the staging area. This means that, okay, we're ready to take a snapshot and put it in this block of time. So you can see this, kind of list with nodes on it. Let's call that a linked list for those of you that are familiar with it. The blue is our current snapshot. So what we would do is we would commit our staging area to the most recent part of our commit. So what it would do is we say, okay, this is our current commit. We want to put this snapshot in this instance of time so that we can come back to it later if we need to. And this is all done locally. Now, if you want to push it to something that can host it off of your computer, like a remote repository, you can use GitHub. So GitHub is probably what most of us are going to be using. We'll have documentation for those that aren't familiar with it. But essentially, we have this chain of events, chain of snapshots. What we want to do is push it to another computer, or push it to the internet so that we can pull it on a different computer, or maybe one of our project partners can pull it on their computer. So what we do is we push it to the remote repository. So it literally just takes everything that you have on your local machine and it puts it on GitHub or any other Git hosting service. So this right now we've only been focused on making changes, committing them in a linear fashion, but Git can get much more complicated than that. So branching. So we have this branch, and we're just calling it master. What we want to do is we want to test something, but we don't want to put it on our master branch because that's like our official thing. So what we do is we create a branch called feature, which is going to be the thing that we're going to be testing. So what conceptually what branching does is it creates a fork off the current branch at that point in time. So you're on your most recent commit. So let's say that we only had just this. So over here, we only had this AB. What we're going to do is branch off from that and push all of it. And we can keep working on these independently now because they're two different entities at this point. And you basically have an additional instance of your project that you can work on. And this is pretty good for creating separate testing environments. For example, something that's really, really common, is having a feature branch, a dev branch, a master branch, and a release branch. Release is something that you would show to the world. Master is like your official thing that's ready to be released. Dev is something that you develop on. It's like your general development environment. And feature is something that you would create a specific feature for and then merge it into dev. Merging, we will get into soon. But what I want you guys to take away from this slide is that you guys can create different environments from from a specific instance and work on them independently. Now, if you want to, let's say, push them together again, that's called merging. And you may want to do this because you might be testing something out and you realize this is amazing and we want to push it to our official version of our project. That's when merging comes in. You literally just merge one branch into the other. And what this does is this adds the current differences to the branch it's merging to. So let's say we're on our feature branch, we added something that's completely revolutionary. We want to add it to our product. What we do is we merge it into master. And this takes all the differences that feature has and it adds them onto masters. And after it's successfully finished merging, it's safe to delete it so that you guys don't work on the same feature thing again. It's very bad convention. Rebasing. So rebasing is a special form of merging. So it's the same thing as merging, but you add the entire history to the tip of the target branch. So if you see over here on the merge, what we do is we keep the history and we just merge it into the most recent part of the master branch. But for rebase, essentially what happens is we kind of collapse them onto each other so that the feature branch ends up being in front of the master branch. So you don't merge them into one node. You kind of just add the tail, essentially just add the tail of the feature branch to the head of the master branch. And this rewrites the history. So that means that when you rebase from a certain branch to another, you have to find out all the differences and it will literally rewrite the history. So that's actually, and it makes it seem like you only ever had one branch because afterwards it'll only show one branch even if you go into the commit history. The only way to tell would be to have some kind of message that says, we're rebasing and we're pushing it together. Now, get a drink of water, excuse me. So now you might be wondering, what's the difference? Why would we use merging over rebasing? So for that, here's two important parts. It's literally just the history. So merging conserves the history. When you go back, you can see how it diverged and converged back into the master branch when you're working on some kind of different branch. Rebase rewrites history. So there's different scenarios where you might want to do one or the other. So for merging, do this if you're working on a very large code base, you have multiple collaborators, and you have a lot of distinct features. So this keeps people accountable in terms of who's working on what feature, and it makes a little more sense when you go back into the history and you can tell where certain changes came in. For rebasing, you wouldn't be able to do that because it would just be one entire like chain. So one question in the chat is, can you merge two different repos? No, repositories are held separately. I think there may be something fancy you can do with how you set up your origins, which we'll talk about. But in general, it's not a good idea to like merge two repos together. I'm not particularly sure how you would do that. Generally, repositories are instances of a certain project, and they're generally kept separate. So if you have a program in one repository that only prints dog and the other repository only prints cat, you wouldn't be able to converge them into one repository. So we'll get into what repositories are in just a little bit. So rebasing, if it's your personal code base, it's literally just you working on it. The only thing you really want to keep track of is when something happened and not necessarily how or at what point in time something happened. So that's when you would go into just using rebase. So large code bases, just keep it at merging. But this topic is actually a topic of discussion. So this is something that you can find debated all over the internet, but this is just something that I've compiled over like looking over different kinds of features, different websites. So merge conflicts, the most hated thing in Git and the bane of programmers' misery. So what happens when you have a hello world program, and let's say you create two different branches. One changes it to hello cat, and the other changes it to hello dog. You guys changed the same line and the same word to a different word. So that means there's two different instances of this program where you created, and they're different. What would happen if you tried to merge them? How do you figure out which one takes precedence? So how do you figure out which one to choose to go on to the main branch and the one that just gets completely deleted? Let's see. How is rebasing rewriting history? So this is like this is more of a technical thing, but when I say rewrite history, I mean that it goes into it goes through the history of where. Let me actually go back. So over here, what you would do, what the feature branch essentially ends up doing is it starts here, and you have to make sure that at each point in time you can match like you can match the history. So let's say over here there's a difference here, it would actually end up creating a merge conflict. And this is something I ended up tearing my hair out for and figuring out how to fix these merge conflicts. So it preserves history from both master and feature branch. So I'll have to get back to you guys on that one, because basically what I've ended up experiencing is that it ends up rewriting the history. Maybe I did it a certain different way. Shane, could you write that down? Or Ryan, could you write that down so that we can get back to them? So merge conflicts, you have two branches. Both of them have changed the same line, and now you want to fix them. So how do you figure out how to do that? So Ryan, let's get the Git demo. So we have here, a GitHub repository. You guys can create an account, and you guys can create a repository, and it's going to end up like this. So generally what you want to do is you can either SSH to bring it to your desktop, or you can clone it, which literally just brings a copy of it. So what I'm going to be doing is I'm going to be cloning it into Git demo. So here's Git demo. So I'm going to open up the command line here. This is going to say, so I copied this link over here, and I'm going to say in this Git demo folder, git clone. Now git just means call the Git program, and we want to clone a remote repository. So git clone, and I'll paste this in here. Whoops. Let me get this. And it's going to be cloning it into this folder, with the folder name being the name of the repository. What you can also do is follow the instructions here. It's just another way of doing it. You can go into that repository, type in git init, you can commit it, and then you can push it to the remote branch, and that can be pretty much the exact same thing. So you don't have to have git init first. What you would do in git init, it really doesn't matter which path you take. You can clone it, or you could do it from the command line. And git init, so since this is a blank repository, git init would create a local repository and then push it to this blank repository, which would then accept it. What I'm doing is just completely cloning the blank repository, and then I'm going to make changes to it. So you'll see here, I have conflict demo, and I have this command line. So you can see conflict demo. We're going to change our directory into it, and now we're here. So what we want to do is have me push a hello world.txt file. So we use the previous commands, hello world.txt, and what I'm going to do is edit it so it says hello world. Now I want Git to track this file, so I'm going to save this, and if I do git status, which shows the current status of the repository, you'll see that we have untracked files because this is a file that we haven't added to the staging area that I mentioned before. So what we do is we do git add, which adds files to the staging area, and I want to do hello world.txt. So if I do git status again, it says that it's added to the staging area, it's ready to be committed. So let's say, so we're going to do git commit. Git commit means I'm going to take a snapshot of this in this point in time. And I do -m to add some kind of label. So I'll just say this is the first time I'm committing it, so I'll just say initial commit. Now, since this is local, we want to push it to GitHub. So what we would do in this case is say git push origin. So this just says that this is the original repository that we're pushing it to, or that it was cloned from. And we're going to be pushing it to the branch called master, because that's the default on initial branch. Yes. So let's see, we should wrap up soon. I think we can continue off next time in merging and stuff, but since I pushed it, you can see that it showed up here. So you can see hello world.txt, and I can actually drop the link in the chat, and you can see for sure that it says hello world. It has hello world.txt and it says hello world. I think we're over time, so that's the end of this lecture. I use a Corsair K60 something keyboard. Yeah. What is the other options instead of origin? We're going to go into that next lecture, so we don't want anyone to miss out on that. We were going to get into it, but we ran out of time. If you don't specify master, it wouldn't know, which I guess you could do git push, which basically says push to the current repository, the current branch that I'm on. So if I was, let's say, if there was a hello dog branch and I want to push to that while I'm on master, I would do git push origin like dog, if that was the name of the branch. But if you want to do just your current branch, just do git push. Is there an OS that is the most ideal for coding? I honestly don't think so. I think every OS has its perks and benefits, but people can debate that all day. If you guys want to stick around for like 5 minutes, ask questions. But other than that, we'll have an announcements post on Saturday after we send out the enrollment codes. And that's it. Thank you guys for attending today's lecture.